Hey, this is 1.4 still, just an extra example to show how you can calculate the perimeter and area, specifically either using the distance formula or the Pythagorean theorem. So I'm given three vertices, P, Q, and R. You can probably tell ahead of time before I graph anything that the polygon is going to be a triangle. So I'm going to graph each of those points. I notice everything's in quadrant 1 or quadrant 2. So I can make my x-axis a little bit lower than I normally would. Here's my x-axis, and then the y-axis put right in the middle. So to graph each of the points here, 1, 3, that's in the first quadrant. I'll label that. That's point P. 1, 1 is point Q. And then lastly, R is -4, 2. So I have my triangle, either PQR, RPQ, QRP. And to calculate the perimeter, here's one of the side lengths. That should be easy enough to find. I'm just going to label it here. I can write it off to the side if I want. This, remember, is the length of PQ. If I don't put a little segment symbol above it, that's 2 units in length. To find the length of RQ or the length of RP, you could do one of two things. I could use the distance formula. Q is 1, 1, so I could label that x sub 1, y sub 1, and then R, x sub 2, y sub 2. So I could use the distance formula. Or here's something else I could do, which in reality, it's actually doing the same thing. I could use a right triangle. So here's RQ. RQ would actually be the hypotenuse of the right triangle. I can make the right triangle above RQ, or I can make it below. It actually doesn't matter. Both of them would be congruent triangles, even though we haven't talked about that. So here's the right angle. This length right here, just 1 unit in length. This length right here, even though I don't have this labeled, 1, 2, 3, 4, 5 units in length. So to find the length of RQ, I could use the Pythagorean theorem. A squared plus B squared is equal to C squared. So 1 is either A or B, and then 5 would be the other. So 1 squared plus 5 squared is equal to RQ squared. Or I could just let that be C. It actually doesn't matter. I'm going to use a single variable. So it's equal to C squared. I'm not going to go through, maybe later on in like our lifetime or something, you're not sure what I'm talking about, but I'm not going to go through and use the distance formula. We'll get the exact same thing if you use the distance formula, because really the distance formula comes from the Pythagorean theorem. So 1 squared is 1, plus 5 squared is 25. That's equal to C squared. C squared, I'm just going to change side here, is equal to 26. So to solve this for C, I could take the square root of both sides. C is equal to the square root of 26. If I want to round that, I could use my calculator. It should be about 5.1, a little over 5. So I take the square root of 26. .09, so yeah, about 5.1. And so that's the length of RQ. About 5.1. And you can do the same thing with RP. Either make a right triangle or use the distance formula between points R and P. If you're a little bit observant, you would notice that it would be the same length as RQ. So you could save yourself a little bit of time. Notice that RP is the same length as RQ, about 5.1. So then to find the perimeter of triangle PQR, 2 plus 5.1 plus 5.1. So that's going to be to the nearest tenth, since I rounded sides RQ and RP to the nearest tenth as well, about 12.2. Similar to the last example, no units were given, so it'd just be 12.2 units. Okay, in order to calculate the area, here's what I was talking about on the last video. You might need to look up a formula. I could use area for a triangle, 1/2 base times height, or base times height divided by 2. Here's what I'm going to do. I'm going to let PQ be the base. So if you want Like you could redraw it. This definitely is not to scale. Here's side Q, or sorry, vertex Q, here's P, and then here's R. But QP, definitely 2 units in length. So I'm going to let that be the base. Then the height of the triangle would be from R. That makes a right angle to QP, or it's also called as perpendicular. So this right here, that segment would be the height. And then that segment would be, or is, 5 units in length. So that's the height. Then I could use the area is, some of you might say base times height divided by 2. I usually just say 1/2 base times the height. It's the exact same formula. 1/2 base, which is 2, times the height, which is 5. And it actually doesn't matter what order you do things here. I could take 1/2 of 2, 1, and then multiply it by 5, 5. I could take 2 times 5 first, 10, and then multiply it by 1/2 or divide it by 2, still 5. You can even take 1/2 of 5 first, 2.5, and then multiply by 2, still 5. But then the area would be 5 square units, or 5 units squared. But depending on what type of polygon you have, there's different formulas for different areas of different polygons. But in this case, 5 square units or 5 units squared for the area.